Hi everyone, our next topic is Q. Q is another type of data structure, another type of linear data structure. So far we have discussed what is an array, what is a stack, and now we are going to study about Q. Okay, Q is also a linear data structure like stack. In the elements of the queue are also arranged in a sequential or ordered way. And one thing from stack is top is the point where, or top is the element where you can perform the push operation or pop operation. Okay, the element at which the top pointer top is pointing, that element is undergone the operation push or pop operation. Okay, there are two basic operations there, push and pop, and these are the basic thing that we have studied from stack. So now we are going to study Q. So we can comparatively studying these two things. Okay, then what is the definition of Q? Q is a linear list of elements. Q is a linear list of elements, means the elements are arranged in a linear way, one by one or sequential way, in which deletion can take place at one end called the front. Okay, the main important thing is in a queue the deletion operation can take place or can take place only at one end. That end is called front. Okay, in the case of queue you can see two end there or two pointers. In the case of stack you could see a top pointer. So like a queue there are two pointers or there are two ends. Okay, at the front end or the end which is named as front, at that place you can delete the elements. Okay, and insertion can take place only at the other end called the rear. Okay, there are two ends in a queue, the two ends named as front end and rear end. Okay, at front end or the elements which is present at the front of the queue or the front portion of the queue, you can just delete the element that front from the front end. The elements you can insert into the queue which is pointed by the rear end. So remember there are two ends for queue, the front end and rear end, and the two basic operations of queue. The first operation is Enqueue, second operation is Dequeue. Okay, in case of queue you are about to familiarize what are the things. The front end is there, rear end is there, and the two basic operation. First one is Enqueue. Enqueue means insert an element. Where we can insert the element? Insert an element at the rear end of queue. Q, I have already told, Q have two ends. For the first one is rear end, second one is front end. At the rear end you can insert the element. And the case of DQ means delete an element. At the front end you can just delete an element at which the front end or front pointer is pointing. Okay, there are two basic operations, NQ and DQ. So here there is an example for you. You can see it is marked as one way. It is a one way pathway. Then first in first out, the first vehicle is the jeep, which is the first vehicle which is entered into the one way pathway. Then the second one is that black car, third one is that white car, and fourth one is the fourth car. So that is the last one. Okay, you can access this last car only at last. Okay, the first which is entered is the jeep, and you can access or you can get the jeep at the first time itself. Okay, that is the difference between first in first out and last in last out. That is the way of inserting, or that is the way of accessing elements from queue. Okay, the first in first out mechanism. That means the first element which is entered into the queue can be accessed firstly. Okay, the last element which is entered into the queue can be accessed at the last. Okay, what is in the case of queue? In the case of stack, you can get the first element which is inserted at the last time. Okay, because that is LIFO type of A LIFO type of accessing elements. What is the LIFO type? Last in, first out. The element which is inserted lastly into the stack, that element is accessed firstly. That is why in stack the elements are arranged in LIFO manner. That means last in, first out manner. In the case of queue, you can access the elements or the elements can be accessed in first in, first out. The element which is entered firstly into the queue can be accessed firstly. That is first in, first out. So also you can say it in another way, last in, last out. The element which is entered or inserted lastly into the queue can be accessed at last. Okay, that is the difference between last in, first out. Last in, first out is used in stack. First in, first out is used in queue, or last in, first out is used in queue. Okay. Queue is an abstract data structure somewhat similar to stack, that we have already told. Queue is a linear data structure, or it is also called abstract data structure, and which is somewhat similar to stack. Okay, in contrast to queue is opened at both ends. That both ends are called front and rear. You know that stack is opened only at one end. That means at one end, and the end which is pointed by the top pointer. In the case of queue, the queue has two ends and the queue is opened at both ends. That two ends are called front and rear. Okay, the one is always used to insert data. The one end is used for inserting the data into the cube. Only for that purpose we are using one end, that is the front end. So inserting the data is called Enqueue. And the other end is used, the other end is the rear end, which is used to in order to remove the data. That means DQ. The operation is called DQ. DQ means deleting the element from the queue, and it is performed at the rear end. That is the difference between front end and rear end. Queue has two ends, that is front and rear. The operations such as Enqueue and Dequeue are performed at these ends respectively. Okay, queue follows first in, first out methodology. That is, the data item stored first will be accessed first. That we have already seen here as an example. First element which is inserted into the queue will be accessed firstly or at first. Okay, so queue follows first in, first out, whereas stack follows last in, first out mechanism or methodology. Okay, in queue operation you can see Enqueue. Okay, what are the queue operations? That is Enqueue. Enqueue means storing item at the where we can store the item or we can insert the item. Store means inserting or adding or storing the elements into this queue. Okay, at which end? At to the rear of the queue. That means to the rear end of the queue. So Enqueue means add or store an item into the rear end of queue. Then what is the other operation? What is the other operation is DQ. Okay, DQ means remove or access the element, an item from the front of the queue. Okay, you can delete the item or you can access the item from where or the at the point which is pointed by the front of the queue. Okay, from the front of the queue you can DQ or you can remove an item. Okay, that is the difference between Enqueue and Dequeue. Enqueue is performed at the rear end of the queue. Dequeue is performed at the front end of the queue. Then queue has two pointers, front and rear, and you can see as an example here. There is a stack. Okay, stack can be seen in most of the cases. Stack can be seen as a horizontal arrangement. Okay, whereas queue can be seen as a horizontal arrangement, whereas stack can be seen as a vertical arrangement. Okay, because there is only one end. In the case of queue there are two ends, so in order to understand it clearly, we are arranging the stack in a horizontal way. So DQ means what? Deleting an element. Enqueue is what? Inserting an element. So inserting the element at the rear end. Okay, you can insert any elements into the queue at the rear end of the queue. Okay, we can delete an element from the front end of the queue. Okay, that are the 2 pointers used in queue. So you can see a queue named as a small letter q, that is the new queue, that means queue, this is the queue there. Okay, queue indicates this is the queue. Okay, q is the name of the q, small letter q is the name of the q data structure. Q.NQ means what? We are going to insert an element named as a into the queue. Okay, we are going to insert the element which is named as a into the queue, small letter q. So what will be the queue, the status of the queue? Queue is, you can see a small letter a is placed at q. Okay, the next is q.NQB. We are going to insert an element named b into the q, small letter q. So q gives a comma b. Okay, then you are going to insert an element named c into small letter q. Then the q will be like this, a b c. Okay, accordingly you are placing a as first, b c. Okay, so the q can be seen as a comma b comma c. Okay, then q.NQD, d is also placed in q. Then q.DQA, q.DQ means you are performing a deletion operation on the q named as small letter q. Which element is going to delete? An element named as a is going to delete. So you can delete an element a from the q. So the after deleting the element a, your q data structure will be shown like this, b c d, and same as in the case of b is removed from q. Then you can just NQE. NQ means insert an element e, that is performed at the NQ is performed at the rear end, because NQ can be always, NQ will be at the right side of the, NQ is performed at the right side of the Q. So C comma D comma E, E is inserted into the Q named as small letter Q. Okay, then DQC. DQC means you can delete the item named as C from Q. So C is deleted. So the rest of the elements are D and E. So DQD, D means you can also delete another element named as D from Q. Okay, that is first in first out. You are studying about, you are viewing the first in first out mechanism. Okay, the first element which is inserted into the Q is deleted first. Okay, then elements of a queue are processed in the same order as they are inserted into the queue. Here A was the first element to join the queue, because here we all know that A is the first element which is inserted into the queue, and that element is accessed firstly. So or that element is the first element who are going to leave the queue first. Okay, A was the first element to join the queue and it was the first to leave the queue. Okay, if A is the first element which is inserted into the queue, A should be the first element which is leaving the queue also. That is first come first serve. That is first come first serve mechanism, or first in first out mechanism. So first in first out is the methodology which is used in queue. Okay, then we are going to study the array representation of queue, how we can represent this type of queue data structure in the form of array. So we need to understand, or we need to consider different things. Which are the different things? A rear end will be there, if an entity named as friend will be there, and what NQ operation, DQ operation will be there. These are the operations. Okay, so we are going to study how a queue is represented using an array. Queue can be represented using a linear array. So we need to indicate 2 pointers. Okay, there are 2 pointers called, which are the 2 pointers, front and rear, which is used to indicate 2 ends of the queue. Okay, front and rear are the 2 pointers which are used to indicate the 2 ends of the queue. Okay, then this is the array representation at the index named as 1 2 3 4 5 6. The sizes of the array is 6. Okay, then AAA is inserted, BBB is inserted, CCC inserted. So here at initially the front equal to 1, rear equal to 4. According to the elements which is stored in the array, you can assign the value of a front as 1, because front as 1, the at 1 which is inserted AAA as front, and the rear is assigned as 4, because uh, it is the last or element is inserted at the fourth index. So the value of rear is 4. That is the value which we are assigning in order to perform these operations. Okay, front equal to 1, rear equal to 4, according to the elements or according to the number of elements which is stored in the array. Okay, here the maximum size or the max size of the array is 6. Okay, max size of the array is 6. That means you can just add the numbers. Insertion take place at where, and the insertion is taking place. Insertion is take place at rear, and the deletion take place at front end. Okay, insertion take place at a rear and the deletion take place at a front end. That is the important point that you have to understand in this area. That is q, for the manipulation of q or the representation of q, you have to understand what is rear and what is front. At the rear and insertion taking place, at the front and deletion taking place. Okay, whenever an element is deleted from the queue, or when we are going to delete an element from the queue, the value of front is increased by 1. That means what? The value of front is increased by 1. We all know that deletion taking place at the front end. Okay, after deleting the, if we are going to delete the element AAA, so we deleted it, AA is deleted it, the value, the front is pointing as 1. Okay, front equal to 1 here. If we deleted AAA from this particular queue, the value of the front is set as front equal to front plus 1. Then after deleting the element, the the value of the front is pointed into 2. Okay, front is incremented by 1. Okay, similarly in the case of deletion, similarly in the case of deletion, not deletion, adder. If similarly in the case of insertion process, whenever an element is added into the queue, the rear is incremented by 1. Okay, when we are adding an element in this example, if the value of the rear is 4, because at the front rear and you have DDD. If you are going to delete this DDD, then what is the value of the rear? That is the value of the rear and is, if you are going to insert an element as A, B, C, D, E, E, E into at the front end, if you are going to insert an element into the queue, the rear is incremented. At present the rear is indicated as 4. If you want to insert an element, you have to increment the value of rear is equal to rear plus 1. That means the rear end will be pointed into 5, and you can insert the element into the fifth rear equal to fifth index. Okay, so for performing deletion and insertion, the value of the front end should incremented by 1. Okay, whenever you are deleting an element, the front is increased by 1. Whenever you need to add an element, you should have to increment the value of the rear by 1.